Hello and welcome to my presentation about all the new stuff that we have introduced in ScyllaDB Drivers and what's coming next. My name is Piotr Grabowski. I'm a software team lead at ScyllaDB. So first of all, few things about me. I'm a software team leader at ScyllaDB, responsible for all ScyllaDB drivers, as well as ScyllaDB Kafka connectors. We have the sync connector and the CDC source connector, and I've been at Scylla for 3 years right now. So let's go over the presentation agenda. We'll cover mostly those 3 areas, some basic information about the drivers. Then we'll go into more specifics at the example of ScyllaDB Rust driver. And finally, we'll talk more in depth about one particular feature that is quite important for Scylla, which is tablet support, and how this feature will enable the next generation of ScyllaDB and drivers to work even better. So first of all, let's start with the drivers, some basic information. I know that maybe some of you haven't yet tried our drivers, so let's go over them. So in the nutshell, drivers are libraries for different programming languages that you can use to connect to ScyllaDB and execute queries. Performing the queries, there's a lot to do when making the connection, properly serializing and deserializing the queries. So the libraries make it very easy to perform it without having to have an in-depth knowledge about the protocol. Because ScyllaDB is compatible with Cassandra, it makes it possible to use the Cassandra drivers unmodified with ScyllaDB. We actually spent a lot of time to make it possible so that ScyllaDB is as much as compatible with Cassandra as it's possible, making sure that the behavior is as you have expected. So Cassandra drivers work pretty well with ScyllaDB. However, if you want to have an optimal performance and take advantage of additional features that we have at ScyllaDB, we highly recommend you to use ScyllaDB drivers. So some of our drivers are forks of Cassandra drivers. We have taken those drivers and have modified them to work better with Scylla. We'll talk about some of those features at the later slides. And some of the drivers we have started from scratch, and the best example of it is ScyllaDB Rust driver, which is quite popular, and we are happy with how it turned out. One thing that is probably very important to mention, so for example with Java driver, which is a fork of Cassandra Java driver, even though we added some new functionality, your existing application, if it uses a plain old Cassandra driver, it will be easy to move to ScyllaDB driver, as we have not broken any compatibility, so it should be a swap-in replacement. So let's talk about a couple of improvements that we made in ScyllaDB drivers that make it unique compared to other drivers. So first of all, ScyllaDB architecture is based on shards. Those shards directly relate to physical cores in the machine that is running ScyllaDB. Our drivers take advantage of it and send the query directly to a correct shard so that the query doesn't have to move between the cores. We have optimized support for ScyllaDB change data capture to make it even performant for that one use case. And for other features that we have implemented at ScyllaDB, like lightweight transactions, the driver is optimized to perform the query that avoids Paxos conflicts and makes those transactions perform optimally. And finally, the feature that is coming soon is tablet support, and we'll talk about it in more detail in the next slides. But this is quite a big feature that will be very important if you will be using ScyllaDB with tablets enabled. So maybe now that I have an occasion to do it, maybe let's go over some best practices, some basic best practices of using drivers. So first of all, you should always use prepared statements, as it reduces the processing time at server side that is required to re-prepare and reparse the statements, and it makes also token awareness possible. So all queries are always sent to the correct node, which is not possible with unprepared statements. You should also paginate the queries so that large select statements don't return a single large page. Instead, you read the data in chunks. You should always think about using an appropriate retry policy in case a query fails, so that you have the consistency that you want and the query is retried with an appropriate time between retries. And maybe this is a meta tip that you should be aware of, is to use Scylla monitoring. Of course, it doesn't only apply to drivers, but when you look at ScyllaDB monitoring dashboard, you'll be able to see whether you should adjust the driver and the health of your database. You can learn more about the drivers looking at the GitHub repos of drivers, as well as our documentation, such as our open source docs and ScyllaDB University. So now let's move on to ScyllaDB Rust driver and see all the new features that we have made throughout the drivers, looking specifically at one driver, the Rust driver. So the idea for the driver was born during a hackathon in 2020, so almost 4 years ago. So over the last years, we have continued the development of the driver. The driver is now very mature. It supports many advanced features and is used by many of our customers. 2023 was quite eventful for the development of the Rust driver. We had 9 releases from 0.8 to 0.11. We refactored our load balancing code to make it more performant. We refactored our serialization code paths so that it's even more type safe, especially for types like UDTs. We implemented rack awareness, so this is a way to save on costs of sending the data between the zones in cloud environments. And we continued the stabilization of the API as we move towards 1.0. This is one example of the optimization that we did. So this is the load balancing optimization that we optimized. So as you can see, we have really improved the performance of this code path. So now when you make an insert, there are 60% fewer allocations and 84% fewer bytes are allocated, so that the performance of the driver has improved because of this refactor. In 2024, we'll add support for tablets, so that the driver is aware of tablets and is able to route the query directly to a specific tablet. We'll continue on different performance improvements. And our big goal for 2024 is to stabilize the API for 1.0 release, the first stable release of Rust driver. So now let's move on to one big feature that will be added in 2024 across our all drivers, which is tablet support. So let's go over some basic details about how routing queries in ScyllaDB works. So right now, without tablets, when you make a select statement or an insert statement, or maybe even update or delete statement, this this query is routed to some specific nodes. We calculate this information by calculating the hash of the partition key. So this is how it works right now. So this is something that we call vnodes. This is a token ring. So this ring represents the data, the hashes of the partition keys, and this ring is split into many vnodes. If you have some replication factor, one piece of the data is stored on many nodes. The problem with this approach is that this mapping is fairly static. We can't really move the vnodes around, and the driver doesn't really take advantage that this mapping could change. So this is very static, and this makes adding new nodes, removing new nodes more time consuming. With tablets, ScyllaDB now maintains metadata about the tablets. The tablet contains the information about which table this tablet represents and some start and range of data that will store. And each tablet maintains the information about which replicas hold this data that is represented from the start to end for specific table. So the driver will maintain the information about all tablets. However, when we implemented the first implementation of it, we saw that the problem is that the number of tablets could get really large, and the client would have to store the information about all of them and refresh them periodically, which could take a lot of time. So our approach that we implemented in the drivers is that the driver maintains this table, this tablet information dynamically. So in this example, a new tablet has appeared. Let's suppose that the driver wants to execute a query that is stored on this tablet. However, it doesn't know yet about this tablet. So what will happen is that the driver will make a query. It will make a query to some node. It doesn't know which node in particular to query, so it may be query some wrong node. But this node will reply with the correct tablet information. And that way the driver will update its own internal metadata about the tablets. And the next time it sends a query, it will be able to use this tablet metadata and send it directly to the correct node. This approach makes it possible to dynamically refresh the metadata about the tablets. So when you add a node, or maybe if you remove a node and the tablet information changes very rapidly, the driver will get this information dynamically. It won't have to refresh the whole tablet metadata maybe every 5 seconds, which could add a lot of strain on the system. And maybe another benefit of it is that the driver doesn't have to store metadata about all tablets. So for example, if the driver only queries one table, it will only persist information about those tablets for that specific table, and this will get updated dynamically with the mechanism that I showed. Maybe one more thing to add with tablet support in drivers is that with tablet support, it will be more and more important to use our ScyllaDB drivers compared to Cassandra drivers, because without those support, the driver will be essentially not token aware. So it will not be able to send the query directly to the correct node. So currently, when you use Cassandra drivers, the driver, even though it's not shard aware, it will route the queries to the correct node. However, with tablets, the Cassandra driver will not get this information and won't be able to directly route the queries to the correct tablet. So it will be very important to use tablet aware drivers in the future. So that's all. thank you for the presentation, and I hope that you learn a lot about our drivers.